Hello everybody, in this video I'm going to explain my project titled Robotic Object Retrieval or ROR. The goal of this project is, first, to add an extra function to the Roomba by integrating the OWI robotic arm. Second, to develop methods for navigation and object retrieval. Third, to measure the effectiveness of the system by running trials. The video shows the final configuration of the robot. I'll walk you through how I've implemented this system, starting the next slide. This slide shows the hardware configuration of the system. The robot consists of two main modules, Robot Arm Module and Roomba Module. Each module has a microcontroller and performs its own tasks. The control flow of the system is shown in this slide. First, the robot detects an object using camera frames. Then activate the Roomba's motors to approach the object. Once it approaches the object within the workspace of the robotic arm, it hands over the control to the robot arm module. The robot arm module determines the position of the object from camera image frames. Then solve an inverse kinematics to obtain joint variables for the object position. Finally, control the robot arm based on the obtained joint variables. This video shows the Roomba motion control using image feedback. Once an object is detected in the camera, the Roomba approaches the object while keeping the object in the center of the picture until the object falls out of the image frame. The goal of this approach phase is to bring the object within the workspace of the robotic arm. Therefore, I first calculated the robotic arm workspace mapped onto the ground floor. The right table shows joint variables at different height and distance. Columns highlighted in yellow color correspond to valid configuration space shown in the left figure. Then I determined that workspace lies between 16 cm and 25 cm on the ground floor. This slide describes the camera configuration for the robot arm module. Camera cannot be attached to the center of the end effector, so I gave up using the feedback control based on the image frame coordinates. Instead, I've attached the camera in the vertical direction, which indicates that I have to determine the position of the object in the world frame coordinate and calculate inverse kinematics. The first thing to do is conversion from the image coordinate to the world coordinate. One challenge here is that the view of the selected camera is distorted and blocked by the end effector, which requires two-dimensional nonlinear calibration. To avoid that, I introduced a trick here, which is called TwoStep Motion. First, the system aligns the end effector's axis to the object. Then solve the inverse kinematics for the rest of the joints. That way, the system only requires the height z and one-dimensional distance d to solve the inverse kinematics. Then what needed is one-dimensional calibration between the image coordinate c and distance d, and I obtained a good linearity. The next step is solving inverse kinematics. The robot arm is already aligned to the object, which means Q1 is already solved. Also, I have obtained the distance d from image frames. So, what else needed is the value of z. Z is usually determined by 3D profiling of the object, such as by stereo imaging or LiDAR, but they are expensive. In this project, I used an assumption that height and size of the object is known. Then I solved the inverse kinematics, as shown here. For the control load, I used the bang control. The system reads the current angle values from the potentiometers, and then calculate the control input based on the difference between the target values and current values. This is the result of the demonstration. I threw a colored block to different positions randomly, and then measured the success rate for 10 different cases. As you can see, the system was able to pick up the object for most cases, but failure attempts were also observed, such as in the left bottom and right bottom. I obtained 8 successful attempts out of 10 trials. As seen in the video, even in failure cases, the robotic arm navigated the end effector to the object position successfully. Therefore, those failures can be avoided by improving the gripper design, which is good task for future work. I'd like to wrap up the presentation with this slide. Thank you very much for your attention.